Are the following systems of linear equations consistent? So, consistent just means we have at least one solution. That is, there's either a unique solution or many solutions. If we're not consistent, that just means no solutions at all. Now, the only way we can get no solutions, if we take our equations, row reduce, go down to row echelon form, I would need to wind up with a false statement. So that would be something like I have 0 equal to a non-zero number, or two numbers that are not equal to each other being set to equal each other. Now, first example, take x minus 3y plus 2z plus 2w equals 1, 2x minus 2z equals 3, and then 4x minus 6y plus 2z plus 4w equals 6. I set up an augmented matrix, so that just means we peel the coefficients off, load them in, and then I'll put a bar in where I have the equal signs. So from here, we want to go to row echelon form. To do that, we have a 1 in the upper left-hand corner, so I want to turn the 2 and the 4 into zeros. I do that using row operations, so I'll take row 2, subtract off twice row 1, and I'll take row 3, subtract off 4 times row 1. When we do that, we get the matrix here. Then I'm going to want to take row 3, subtract off row 2. What happens then is I wind up zeros along the bottom and then a 1. Now, if we rewrite that in terms of equations, that just means 0 equals 1, and that's clearly false. So that means I can't have any solutions. If I try to find a solution for all three variables at once, we're going to wind up setting 1 equal to 0, and that's not good. So, not consistent. How about if we change, this number here in the corner? I'm going to change it from a 6 to a 5. Then what happens? Same procedure. We set up our augmented matrix. We're going to do the same row operations. What will happen then is, when I get to our bottom row, instead of getting 0 equal to 1, we have 0 equals 0, and that's just fine. And then we note, we're going to have many solutions here. Because we're going to have pivots in our x and our y columns, that means in our z and w columns, I have free variables. So if I have free variables, that means I'm going to be able to choose those variables to be whatever numbers I want, and they'll keep producing more and more solutions. So in this case, our answer is consistent because we have many solutions.